Okay, during this test, let's just get stuff together there. You can see that here I've got a ring, a ferrite ring, just normal ferrite ring, with quite a few turns of enamel copper wire on. I've also got a secondary over wire, which is quite coarse. It's probably, I don't know, 6 or 8 turns over the top of the primary. The primary is connected to the controller using both FETs connected together. I've got my clamp diode there across my coil. Now the scope at the moment is connected with the negative of the scope to the FETs, with the scope probe connected to the supply side of the coil. Anyway, I'm going to do a scan now. Let's turn that around. Okay, we're set at 1.039 kHz, 32 nanoseconds pulse width, and at the moment the phase is 0. The scope is set to 20 volts per division, and I'll move that in and we'll go to 100 nanoseconds. Let's get this going there. Okay, well, 100 nanoseconds per division. So I'll start the sweep now. (20 nanoseconds), 40 nanoseconds, 60 nanoseconds, 80 nanoseconds, 120 nanoseconds. Anyway, you get the idea of what's happening there. As you can see, I'm just going to scan back down and go back down to 0. 100 nanoseconds, 80 nanoseconds, 60 nanoseconds, 40 nanoseconds, 20 nanoseconds, 10, 9, 8. I'll stop it about there. It's not on 0, it's on 6.25 milliseconds. Now what I'm going to do is I'm going to disconnect the scope and swap it around so the scope negative is now on the supply side of the coil and the probe is on the FET side of the coil. I need to just turn my inversion on. And look what we've got there. Well, that is totally different to what we had when it was connected the other way. And that's 250 nanoseconds per division there. So that's 250, 500. We've got 1 microsecond pulse. So I don't know what's happened, but just swapping the scope positive and negative over has given us a totally different waveform. And if I do a scan, nothing changes. I'm zooming on the time base, that's 1 microsecond per division there. And I'm scanning 40 nanoseconds, 60 nanoseconds, 80 nanoseconds, 100 nanoseconds, 120, 140, 160, 180, 200 nanoseconds. Right, I'm going to stop it there for a second. Okay, we're at 203.25 nanoseconds. Now I'm going to take my secondary overwind on the ferrite core and I'm going to short them out. So in effect I'm putting shorted turns onto this toroid. See what happens to the pulse on the screen? There we go. Right, that's my shorted turn now. or shorted 6 turns. So I'll go back to 106 nanoseconds. There's our 106 nanoseconds, 20 volt per division still. We're on 203.25 nanoseconds phase shift. Now I'm going to start scanning down 200 nanoseconds. 180 nanoseconds. 160 nanoseconds. 140 nanoseconds. 120. 100. 80. 60. 40. Now in a minute, when we go beyond 0, it's going to roll over and go to the maximum phase shift, and that's quite interesting. I'll have to zoom in on the time base when it does that. It's going to do it now. Okay. Now look at that. We're at 1260 nanoseconds. The scope is set to 500 nanoseconds per division. Triggering's a bit dodgy. 1200 nanoseconds. In fact, what I'll do, I'll go up and increase the resolution on the increment for phase, and speed it up a bit. I'll move it from 0.25 to 1. See where we go with that. We're going down in single nanoseconds now, so it's much faster. 1000 nanoseconds. 900 nanoseconds. 800 nanoseconds. 700 nanoseconds. 600 nanoseconds. I can increase my time base now. That's 100 nanoseconds per division. Phase is 400 nanoseconds now. 350. 300. 250. 200. 150. 100. 50. 0 and back round again. Right.